Well, good morning. Adam Smith here. Thank you all for joining us for our Taurus Agronomic Bites podcast. It's our second one of the season. We're pleased to do the better utilization of the soil we have. So we're honored to have Marc Béland with us, joining us as a special guest. We'll get to some introductions shortly. Just a few housekeeping items for the people logged on. We do have 4 resources on your side toolbar for some reference. And for the people listening in, if you want to log on to our website, www.taurus.ag, you can get all the resources there. And if you're looking for another good resource, Premier Tech is a good one as well, www.ptagtiv.com. And we'll have those posted at the end of the podcast as well for everybody. So if you have questions as well, you can ask your questions and we will answer them as time permits or as soon as we can. If we don't get to them, one of your Taurus reps will be happy to follow up with you afterwards, and we can answer your questions for you. So I think that kind of gets all the housekeeping items out of the way. Again, I'm Adam Smith with Taurus Ag Marketing. I've been with Taurus for 6 years. All of those years, I've worked really closely with Premier Tech Agriculture, bringing the AgTiv line of inoculants with Taurus to Western Canada. I guess maybe one thing about me is I own and live on a farm in Southwest Saskatchewan in a little town called Beachy. So I'm going to ask Darren to introduce himself and before we talk to Marc Béland.
All right, thanks, Adam. Thanks, everyone, for joining us today. My name's Darren Smith, and I haven't been with Taurus very long, closing in on a year now, but have been working with biological inputs and inoculants for majority of my career in agriculture, which is well over 20 years now in Alberta mostly. So have spent some time in Saskatchewan as well and Manitoba early on in my career, but Alberta for a majority of it in the south.
That's good, Darren and Adam. Thanks a lot for having me here on the podcast talking about soils. I am director for Premier Tech Agriculture. I've been with Premier Tech for over 20 years. And a little bit of my background, I studied and went to university in Concordia in Montreal, where I got a master's in biology and did a lot of work with the topic that we're going to be talking about today, biology in the soil and how they affect plant growth. So that's a little bit about me. Currently living in Eastern Canada, right close to our head office, and currently living by the lake, where we're doing this podcast here today. So looking forward to spending a little bit of time with everybody on the call and with my colleagues Darren and Adam here today.
Thanks, Marc. I guess maybe a note as well, you lived in Swift Current for how many years while we were getting AgTiv going with Taurus?
That's a good question. I lived in Swift Current between 2011 and 2018, where I set up shop there in Swift Current, which was our target focus area to bring some Premier Tech products into the pulse market. And then after in the fall 2018, so going to be coming on 2 years now, came back to head office to be closer to the family and also manage North American sales for Premier Tech Agriculture.
Sounds good.
And by the way, I really enjoyed my my time out in Saskatchewan. I thought the farming community and colleagues in the farming community were very very welcoming, very nice, and learned a lot about large scale farming. So it was really good experience.
Awesome. Thanks, Mark. Just on a family note, Darren and I are not related, so you can mark that down. Just because we're Smiths doesn't mean we're all related. So anyway, we're talking about utilizing our soil and how it relates to agriculture. So when I got my farming hat on, we're all going to a little bit wider and wider row spacings, bigger drills, wider row spacings, so we can get them all pulled and get across some large farms. So but do we ever really look at what the impact is when it comes to the rooting zone of doing that? So we just want to start off by running that scenario, making everybody think, right? Say a wheat, we're looking at wheat at something like 30 plants per square foot, maybe even more in some cases. Well, on a 12-inch row spacing, we're trying to jam 30 plants per foot of row in that seed row. So, essentially, what does that do to the roots? We want this nice stand. We want to keep it so it doesn't tiller a whole bunch. It helps with our disease management. But, when you jam that many plants per foot of row in, what's it doing to that root architecture? So if you just play along, we take it down to a 6-inch row spacing where you got still our 30 plants per square foot. We're only going to put 15 plants in that, that actual row. So, what does that do to our roots? You'd think that's a huge impact of where our root can actually spread out and spread its wings a little bit. We're not jammed up against the next root. So, where does biology fit into that? Can we actually, use biology to help those roots expand the soil a little bit more? So now we know, the logistics of farming. A 6-inch row spacing is probably not going to work for a lot of people. Pretty hard to pull an 80-foot drill with 6-inch row spacings in the ground. So, just logistics have to play a part in it too, but just be aware, it's something that we don't really talk about that much. So, how can this biology do? Do you guys want to, start, I guess? You got any ideas of stuff that'll increase our rooting zone a little bit, right?
Well, biology's can play a big role in that. There's a lot of biology going on in the soil, as we know, and mostly good, actually. But in the past, we've always concentrated on the bad for the most part. But can't really grow a crop without soil biology, and a lot of them act like root stimulants to help root growth, stimulate longer root growth, and some act like root hairs to expand that rooting zone of different crops to help explore all that soil.
Maybe we should look at it from the other side is, what's native prairie? We talk about farming community and, zero till and conventional till, but maybe we got to take it really back and just go like, what's the native ecosystem like? Maybe that's a question for Mark. How can we compare the two, or, what are the differences between just, what's undisturbed? How does that biology look like compared to what we're doing?
Well, that's a good question, Adam, and it's a good, I guess, reference point to start off with. In natural prairie ecosystems, you have perennial plants that are going to grow year after year. And, when you really think about it, nobody really goes out and manages a lot of the natural prairie lands or even forests. And what plants rely on is a lot of the biology in the soil to give them a hand. A lot of the fungi and bacteria that are found in the soil, a lot of their functioning is for decomposing organic matter, helping to cycle nutrients, and then make those nutrients available to the plant system in those undisturbed natural ecosystems. So, you know, biology together with plants and the soil, they kind of know what to do between themselves and amongst themselves. They've grown up together, so they each have their own functions, and good healthy soil has a good balance of good bacteria and fungi that'll help cycle those nutrients. But if you compare to our farming systems, well, obviously we're growing annual crops mainly, where you're seeding in the spring and you're harvesting in the fall. And every year you're changing the ecosystem. You're taking the plants off, you're harvesting, you may be doing some soil work. So, you know, the natural way of doing things between fungi, bacteria, and plants doesn't really look quite the same in our farming practices, where a lot of it's artificial, and you're basically reintroducing fertility and good practices to make sure that your plants have the nutrients that they need to grow. And that's where, you know, a lot of the discussion here today on better using what's in the soil. Well, a lot of that function is done by little bugs that you can't see, fungi and bacteria, and that's their role to help make those nutrients available or help plants access those nutrients to improve the growth and make sure that we get good healthy crops and good yields.
Yeah, they really help. Oh, go ahead, Adam.
I was just going to say, even zero till is quite a bit of disturbance from, you know, if we're relating back to a natural ecosystem or prairie or whatever, we're still disturbing the soil quite a bit compared to that. So, yep.
Yeah, you're still disturbing that web, especially when we're talking fungi. You know, it almost like creates a spider web or a web within the soil to translocate nutrients and water and move that around within the soil, and any type of disturbance is going to disrupt that system.
Yep. Maybe just a question for you then, Darren, is, you know, what are kind of common, I mean, I believe we probably got most people on our podcast here from Western Canada, but, you know, what are kind of some common stuff that practices that growers in Western Canada are doing when it comes to, you know, say even just fungus to start with?
Yeah, sure. There's, of course, hundreds and hundreds and hundreds of different types of fungus in the soil. They all perform a different function and compete for space and nutrients, and like I said, perform different functions. And there's actually communication between fungi and plants to reciprocate on that. And, you know, in the past, there's been a real focus on fungi that are harmful, you know, root rots and that sort of thing, and how we protect our plants from that, which is highly important. The past decade or two, there's been a shifting focus to beneficial fungus, where it really helps stimulate plant growth and help with plant health and access nutrients for the most part. And now we're actually seeing introduction of some biocontrols in the greater North American Great Plains, fungi controlling pests. So as in controlling some of those root rots, and even some biocontrol insecticides by fungi. In Western Canada, there's been commercially used fungus for quite a while now. One of them probably the first one that was introduced commercially was penicillium for help solubilizing phosphate. And it's a naturally occurring mold, and just grows in the rhizosphere of the plant and releases some citrates and helps solubilize the phosphate that's otherwise tied up. There's trichoderma that's on the market as well, and that actually acts almost like a bit of a soil, I guess, a root protectant and quasi fungicide, for lack of a better term, on the root. So it keeps that plant root healthy when it's in high enough proportions. But I think the biggest one, maybe not in terms of use, but naturally occurring, and just the whole total weight and makeup of the soil biota is AMF, or arbuscular mycorrhizae fungi. So it's 95% of all plants in the world form a relationship with mycorrhizae, and it's highly dependent on it. And so those are some of the more common commercially available inputs, I guess you could say, in Western Canada.
Yeah, I mean, mycorrhizae is obviously pretty near and dear to our heart here with Taurus and Premier Tech. Yeah, it's super neat, I guess, and Premier Tech's got a really big business with horticulture as well, and been putting in mycorrhizae in the peat mixes for many years, and even naturally, like you say, you get into the forest, right, and the type of an ecto, I believe, right, Mark, in some forest mycorrhizae where they just keep growing and growing, because for us as an annual plant, it's really only growing and we're harvesting. That plant's essentially dying, but those plants or trees that are growing 12 months of the year essentially are still feeding that mycorrhizae network 12 months of the year. So it just continues to associate and bring in nutrients. So agreed. And obviously we brought in Mark to talk about some of his expertise on there, and mycorrhizae being one of them. So Mark, do you want to talk a little bit about mycorrhizae? Maybe mycorrhizae and then some symbiosis. There's a really neat interaction that happens with fungus and bacteria, as we were talking about.
Sure, I can definitely talk about mycorrhizae, but maybe taking a quick step back on mycorrhizae. Darren talked a lot about the fungi that are available commercially. Some may be more known or less known than others, but I'm sure one thing that everybody around the podcast and that is farming can relate to bacteria. The first, or one of the first anyway, biologicals that were actually used commercially would be the nitrogen fixing bacteria. So the inoculants that we use for our peas, lentils, faba beans, chickpeas, and soybeans. So bacteria are obviously very important as well. And speaking on the commercial side, Rhizobia and Brady Rhizobia have been widely used in farming practices as inputs, which have a lot of benefits for the plant. So we're talking about symbiosis and Rhizobium. Well, Rhizobium is also a symbiotic bacteria that forms an association with legumes to basically fix free nitrogen from the air, and they fix that inside of a specialized structure called a nodule, which I'm sure everybody who's dug up a plant has seen those bulgy nodules on a pulse crop, and that's where all the work of the nitrogen fixing happens with the Rhizobia. I know that there are some resources available on the Rhizobium symbiosis and system, but in a nutshell, I mean, it's a fairly expensive, and I'm talking about a biologically expensive process, because it has to build a nodule. So the rhizobia and the root work together to make a little house for nitrogen fixing for the rhizobia, and that energy takes phosphorus, and lots of phosphorus. So there again, some of the importance of proper fertility for our crops. And I guess where the symbiosis and mycorrhizae might fit in there, the mycorrhizae is a fungus, which forms a symbiosis with plant roots, because fungus, mycorrhizae are unlike most fungus, if not all fungus out there, that they actually can't take up sugar, or they can't make their own carbon source for building those building blocks to live. So they have made a deal with plants where the plants will supply the fungus, the mycorrhizal fungus, with sugars for it to grow. And in return, the mycorrhizal fungus will give nutrients back to the plant. So the fungus, the mycorrhizae, like Darren mentioned, makes a web into the soil, has access to a lot more nutrients, and actually takes those nutrients up from the soil, and through a pipeline that's connected to the plant, to the root system, transfers those nutrients back to the root system for the plant to use. It also can access and uptake water as well from the soil. So there's a nice collaboration going on with these symbiotic little bugs, the bacteria and the fungi, with plant roots to make a virtual natural prairie land where your bacteria and your fungi collaborate with plants, and they all work together to make sure that they all survive and all thrive in the soil.
It's great, Mark. And just touch on that, the size and the distance that mycorrhizae can expand that rooting zone. I think it goes back to our first point about crowding that seed row when we're trying to get enough plants per square meter and we have wider row spacing. It's actually quite tremendous, the area that mycorrhizae can expand that root system. I think we do have some data on that, don't we?
Yeah, there's some data that's actually a lot into the literature. I mean, mycorrhizae are studied throughout the world in a number of universities, on a multitude of different topics. But one of them is to show the importance that mycorrhizae have. That you were talking about act as root hairs and building a secondary root system. Well, we've seen in our labs, because it's easy to see in controlled conditions, that the mycorrhizal pipeline that I was talking about, the hyphae, actually can extend out to 10, 15, or 20 centimeters away from the root system to access a lot more soil. So if you think of your 12-inch row spacing, and the distance in between would be 6 inches. So mycorrhizal hyphae can definitely travel that distance in a matter of days or weeks, to be able to help the plant and the root system access a lot more of the fertilizers that we're putting in, just to make sure that we are investing in fertilizers to help grow our crops. Well, we know a lot of them aren't always easily accessible or in the right place at the right time for the root system, and that's where these beneficial fungi play a really key role in helping plants achieve the nutrition they need.
Yeah, exactly. Some are helping solubilize that fact that. Oh,
look
go ahead,
at you
Adam.
guys go. Look at you guys go. I'm talking in inches and feet, and Darren and Mark are talking in square meters and centimeters. You guys are making me feel bad here.
And you're the young one. You should be all over that metric system.
Exactly. I'm right in the in-between. I'm right in the in-between phase, I think. So, but sorry, what I was going to jump in for is, Mark's talking about how many 10, 12 centimeters can go, but, Darren alluded to it is, if we go to our 12-inch row spacings, we're essentially can get 6 inches, 12 centimeters or 15, however much that works out to. That 12-inch row spacing, now we can get hyphae from essentially touching one row to the other. That'd be fair to say, Mark?
Would definitely be fair to say. And I guess a fun fact about mycorrhizae, and I guess fun fact would be dependent on your way of viewing it. But we're talking about the natural ecosystems. Well, one thing that some of these university studies have shown is that mycorrhizal hyphae actually connect different plants together, and they've seen some nutrient transfer between one plant to the other. So it just goes to show some of the diversity and some of the things that are microscopic and we can't really see, even if we wanted to stick our heads in the soil. All of this is microscopic action. But these systems have worked together for a long time, and there are interconnections between plants that also happen with mycorrhizal hyphae. So for sure, the 6 inches or further away is definitely not an issue or a challenge even for mycorrhizal hyphae to span that length.
Yeah. Some more interesting or fun facts, I guess, with that that you touched on is the relationship between land plants and mycorrhizae are ancient. They go back to the time of first plants growing on soil. It was mycorrhizae was the root system. So to establish that, so that's how plants moved from aquatic base when it was all water to land. And then I read a really neat study about some mycorrhizae in the forest setting where you touched on plants sharing nutrients, and they were shown to even between different species of trees, the transferring nutrients from a healthy tree to a tree that was not as healthy through the mycorrhizae web in the soil. So there is communication going on, and I think we haven't really touched on that, but just to even establish relationships on annual crops, there's plants communicate to the mycorrhizae and not just mycorrhizae, but to the soil biota and back. The rhizobia and mycorrhizae send communications between each other to say that we are the right bacteria or the right mold or fungus to establish and to help each other out. So it's pretty neat system, that's for sure.
Yep, and communication is key, just like it is with us humans. It's just as important with bacteria, fungi, and plants. I mean, you need to communicate, and that communication is super important. And those channels are definitely developed and very active.
And another really good advantage of mycorrhizae hyphae is their size. So they're very fine compared to root hairs, and so besides having length, they're able to get into tight spaces and tight pore spaces. So in heavy soils and clay soils where we have tightly packed porosity, then root hairs might have trouble pushing their way through that. But the hyphae mycorrhizae can wind their way through and access those moisture and nutrients farther out where the root hairs wouldn't be able to as well.
Yeah, most definitely. See a couple of questions here in the chat box that I think I can maybe answer one or two of them here. Quite interesting. One question was about, we're talking about Rhizobia and mycorrhizae working together for pulses. But one thing that Darren noted is that, 95% of all plants have an association with mycorrhizae. There are different types of mycorrhizae, but the mycorrhizae that we're talking about here, the AMF or the endomycorrhizae, do form a very beneficial relationship with wheat, with cereals. So the one of the interesting facts on the endomycorrhizae is that since it forms an association with so many land plants, the specificity or the host specificity that we see with the Rhizobia is not necessarily reflected in the mycorrhizal, the endomycorrhizal system, where they're pretty versatile, and they can actually form a lot of good associations with cereals. In a lot of our studies, we've seen that that you can uptake more nutrients and grow more with the same fertilizer that you're putting down. So we have seen positive effects on plant stands, plant health, and also yield on many cereal crops that we're growing. Had a lot of being camped out in or established in Swift Current for several years. Obviously had a lot of eyes on and hands-on experience on the benefits of mycorrhizae with durum. Saw some really interesting positive results of some of our customers using, some of our growers using the inoculant on the cereal side, and being quite happy with the benefits, not only on yield, I would say, but grain quality. We've seen some interesting things related to grain quality. And one parallel or image I always like to bring up at that point is the fact that just like us, we need our vitamins, we need our fruits and veggies, we need to be healthy to fight off some diseases and to be healthy. Well, it's the same thing with plants and with these beneficial bacteria and fungi. Will they help build a healthier plant and help build a stronger immune system for the plant? Not saying that they act as fungicides, but the healthier your plant is, just like the healthier you are, the better chance that it'll be able to fight off some of the diseases.
Yeah, and then just plain old competition too. I think having beneficials in a high concentration gives them a better chance of establishing on that plant than parasitic molds and fungi and bacteria. Just give them a better chance to outcompete for that space on the roots and the nutrients that the plant provide when you have the beneficials in a high number and concentration in that root zone.
Most definitely, yep.
Sorry guys, I'll just jump in here. Sorry, my looks like webcam just got a little technical difficulty, but I think you still got me here. So
okay, great.
Go ahead, Darren.
No, I was just glad you're back.
You never lost me, just technical difficulties, I guess, from beautiful rural Saskatchewan. So I think you answered those really good, Mark. We actually did a really in-depth webinar quite a while ago on mycorrhizae and Rhizobium with Mike Dolinsky and myself. So we do have reference to that on our website, our Taurus.ag website. So if you want to dig into it a little deeper, we can always go through there and look at some resources there as well. But maybe the one thing I was thinking of was maybe stem strengths and stuff like that. Like anecdotally, we've seen some really nice stuff. Just talking about the AMF and the wheat, or even the pulses, right?
Yeah, well, definitely, and without getting too technical here today, but there's a very well-known positive relationship between your stem versus the mass of the root system. So mycorrhizae have and several other fungi and bacteria, but mainly mycorrhizae have a really big impact on root growth and root mass. So actually, as you're building more roots and having a stronger root system, well, a lot of that energy is being put into a thicker and stronger stem. So anecdotally, like you say, Adam, and I think we've seen some of that together, and potentially a lot of you might have seen it out in the field, that we do see thicker stems, especially on lentils. We've seen them stand up a little more, and we definitely have seen stronger stems or healthier plants on the wheat side, which have prevented them from falling over. And we actually have some pictures on that. But there's a direct biological relationship between your root size and your stem width. So as you're building a strong, healthy root system, well, that translates into a stronger stem.
That's awesome. Because you think some of those, you get more into that northern Alberta country, right, where they had lots and lots of rain through there, and maybe some you get wet and not so good a root structure on them. It'd be interesting to see some of the spindlier plants that come out of the drought, or not even drought stress, but you get into the wet stress and flooding scenario, right? So yeah, definitely seen it where you get spindly plants and you go to pull them and there ain't much root structure to those plants.
Yeah,
I don't know. We got about 10, maybe 10 or 15 more minutes. We hadn't really talked much about, Mark talked about a little bit of Rhizobium, but it's keeping with some of the education portion of the podcast here. Some new bacteria that are coming into the marketplace, there's lots of people talking about, and I guess Bacillus would essentially be an easy one to flip to on that standpoint. But when you guys want to tackle, just maybe a brief overview of kind of what Bacillus is doing, or why people are kind of putting it in products, I guess.
Yeah, well, I can do a quick answer, and you can add there, Darren, from your experience in biologicals and your career as well. But for sure, we see a lot of Bacillus out in the marketplace currently. And when you think about it, Bacillus are generally good good bacteria that do have some positive impacts on the soil and also on plants. A lot of the Bacillus that are out there, a lot of the studies that have been done with Bacillus show that there's a lot of compounds that are exuded by some of the bacillus that have been studied, and some of those compounds that are basically let out into the soil have a lot of interesting properties to control bacteria or fungi growth. So I would say that the bacillus have a tendency to be classed into the good guys that you want, and they could have going back to some of the signaling, they could have some molecules or some compounds that'll stimulate some of the root system, but at the same time they could act as providing a barrier or a growth inhibitor to these bad fungi and bacteria that cause root rot and other things. So again, not all bacillus are the same. There are some that exude out into the soil more or less of these compounds. But one thing that's definitely interesting about the bacillus group of bacteria is a lot of them do have those properties to help control in the right conditions some of the bad things that we don't want growing close to our root system.
We've touched on a little bit on what affects growth of their different soil biota or microbiota and soil, like tillage. And we said 95% of the crops have form of association with AMF, but we really haven't talked about the conditions that affect, good or bad, the growth of these good bacteria and fungi that we want. Should we talk to that a little bit?
Yeah, that's a great way to go, I think, Darren, for sure. You want to tackle that?
Yeah, I can start, but definitely would jump in where I have points that I might miss out on, for sure. I think the biggest one where we've talked about is going from native soil to crop production is tillage. It's pretty hard to grow a crop in Western Canada without doing some sort of tillage, even zero till. We are disturbing that soil and breaking that web up of some good bacteria and fungus. So I think that's probably one we have to look at. So every time we till, and some crops you just can't grow without tillage, right? So it really helps to have maybe add some good soil microbes back into that if we're doing that. So just to get the right ones in the right place at the right time, which is another thing we haven't talked about, right? So especially when we're talking rhizobia, there's different thoughts on if we have to inoculate every year, and there's lots of good data that shows that is a very good way to make sure we have good nitrogen production in our pulse crops, is to inoculate every year, even if we're in a fairly heavy rotation. Just getting back to that, the right ones in the right place at the right time. If we're relying on background rhizobia for inoculation, they do survive year to year for sure. They are naturally occurring, but they once the plant dies, the rhizobia that are going to survive are going to naturally select for just that survivability, maybe not so strong in the nitrogen production portion anymore. And they're going to die back to a background level, so they might not be in a high enough population near the roots when you want them to cause good nodulation. So in my mind, obviously we're selling the product, but when you're looking at just a single strain or single action rhizobial inoculant, it is a pretty cheap insurance to make sure that you have good nitrogen fixation and nitrogen to that crop to grow, because to try and rescue it after it, which I've had tried to do with some farmers, is not fun to apply nitrogen fertilizer trying to rescue a bad nodulation.
I think if I could maybe add.
Go ahead, Mark.
Sorry, Adam. I just wanted to add something to what Darren was mentioning about the background or the survivability of bacteria, and you can even say, equate that to fungi as well. Is that it doesn't mean, even if there are some that survive, it doesn't mean that it's going to be right by your seed when you're going to be reseeding the following season. So just thinking about the spatial distribution, we all know that you don't want to take any chances and hoping that the good rhizobia or the good mycorrhizae is right beside the seed that you just planted. You're changing your row spacing, you're changing the seed, and if you think about it, you want to maximize your chances of having a good crop, and that means of having that good biology as close to the seed as possible, so that when the seed germinates, well, it doesn't have to hope and wait for a good guy to come and visit. If there's one right there, ready to go to work as soon as those roots merge out of the seed, well, then you're not losing any time, precious time in your growing season. So you want to make sure that you put that close to the seed, and that you know that you're putting the good one at the right place and the right time.
And the one we should mention quickly as our time's running down is just based on that crop rotation, right? So we rotate away from pulses, background rhizobia go away. But we've also mentioned that 95% of plants host mycorrhizae. There's the big one in Western Canada that we grow that doesn't host it. So then we have to, if we have that in our rotation, we have to make sure that, if you want good mycorrhizae establishment in the next year is canola, right? All of our brassicas and mustards down here in southern Alberta and southern Saskatchewan are a non-host for AMF or mycorrhizae. So it takes quite a while for background levels to reestablish after growing that crop that year. Another one that can affect soil microbial.
We got a really nice study that any one of us with Taurus or Premier Tech can share. How it took 62 days to bring the background population back up to the equilibrium or back to the level before a canola crop. So, I guess I look at it all the time, and we grow a 90-day crop. It would take 62 days to bring those background levels back to, the normal, I guess, call it. What are we losing? What is the opportunity cost there? Should we be looking at the insurance to make that happen, so we don't lose those 3/4 of the growing season, I guess, growing back that biology. But yeah, all good points. I think Mark hit where I was going to go with the row spacings on that. So I think we covered all that off. And, I think the one thing I did want to talk about, we're not going to talk about canola rotation too much. But, I think if Mark can just go over a few minutes here, we talk about some bad stuff in our soil and, the good stuff and how it relates and how it works. That's kind of where everybody gets bogged down in all the information, trying to differentiate it all. But, clubroot obviously is a big thing in, the canola market. You get aphanomyces in the, more of the pulse growing area. It's a really hot topic right now. And, I don't think we got a lot of time to get into it, but maybe if we could dip into, an oospore, a zoo oospore, Mark, maybe this is where your expertise can come in and give us, 5 minutes of just making heads or tails of some of these things that the farmers are hearing.
Yeah, well, definitely a topic of interest, just from a lot of the damage that it's doing to canola and pulses on the aphanomyces side and the clubroot side for canola. And you kind of, unfortunately, biology is smart. they know what to do and when to do it, whether it's good or bad. So, one of the things that these two diseases, the phenomyces and the clubroot, have in common, is that the 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 microbe that's responsible for that is smart. It does a spore structure, so it's relating to, let's say, a plant seed. Well, your seed is there. It's pretty hardy. It can overwinter. Good conditions, it'll germinate and grow. So the seed on the fungus, or these type of fungi, they also produce spores in the soil that can overwinter. And when conditions are right, or they have a right plant that's close by, well, they would, in theory, germinate and cause the damage on the root system that we see with club roots or phenomyces. So the spore itself is a resting structure. A phenomyces, we hear, like you said, Adam, spores. Well, those are basically the type of spores that the mold-like, fungus-like phenomyces makes. It obviously moves in the water column in soil, so it can move thanks to water to hopefully land on a root system, or hopefully not for the farmer. Um, Whereas the responsible one for the clubroot in canola is actually a zoospore. So if you think zoo, well, it sounds more a little bit like an animal. Well, it actually can move itself. It's got a little propeller that it can move through the water column and actually move towards the root system. So I guess the clubroot one is maybe a little bit more adaptable, that it can actually propel itself to reach a root system, whereas the oomycete just basically relies on the water to hopefully land close to a root. So, but again,
the water kind of pushes it down the row, essentially, then doesn't propel itself.
Correct. Yep. Yeah. And again, that's a lot of the kind of microscopic battles that go on in the soil naturally. The phenomyces, or the clubroot, or the fusarium root rot, with these beneficial fungi, bacteria, they're added tools for us to use, and to put all of the chances, or increase your percentage of having a healthy crop. If you're creating a more healthy root system, well, chances are you might be able to fight off some of phenomyces. It is difficult, and it does persist in the soil, but again, on a healthier plant, you might have a less severe disease. Maybe you'll still have some, but it should be less severe when you have some good biology going to war for your plants.
Yeah, I mean, they're dormant for quite a while by the sounds of it. So, that's why they're pretty persistent, but just opportunistic, I guess, right? I think you hit on it. It's all these kind of bad stuff are so opportunistic. I hate to say it's poor rotation, but sometimes, sometimes it is and sometimes it isn't. But environment plays a big role in it as well. I hate to say balance, because you can almost never want to do the balance, but there is a kind of an equilibrium of going back to the whole native prairie, where there's mycorrhizae mycorrhizae, as well as all sorts of fungus and bacteria working together. And now, we got some bad stuff kind of working against us as well. So Maybe just a quick reminder, we only got maybe about 5 more minutes left. So if anybody wants to ask another question, we're kind of caught up on a few questions. We can probably talk all day, but we're going to wrap it up here right at 10 o'clock so we can get everybody on their way and value everybody's time. You think outside the box, maybe, I think Mark, we were talking about, balance and stuff, and it's really no different from plants as it is in humans. When you relate how a human grows to how a plant grows, we need essentially a lot of the same nutrients to live. There's a lot, 18 plus nutrients that we all share that, plants need to grow and we need to grow. But, there's lots of stuff on the whole human gut and biome of your lining of the gut. And, a lot of that is bacteria and, a balance of stuff that's in our body as well, let alone what's in the plants.
See, one of the questions about solubilizing bacteria in the soil, and yes, they are part of the good bacteria. There are some bacteria that similar to what Darren mentioned earlier about Penicillium balai exuding some acids to make some phosphorus more available. Well, some of the bacteria have the same kind of function. They can help, cycle nutrients, make nutrients more available. So yeah, there's definitely some research out there that shows some of the possible beneficial effects of solubilizing bacteria. And one of the things that we try and do is when you're working with multiple different bacteria, fungi in a commercial product, is always to make sure that they are compatible with each other, because the last thing you want to do is have a bunch of things in there and have one counteract the other. So that's one of the challenges of actually bringing some of this biology out into the marketplace, is what to put together, how to formulate, and make sure that it remains alive until you need it.
That's a good conversation, Mark. I think Premier Tech's done an awesome job doing that. We've had mycorrhizae for 35 years, relatively new in ag, but 35 years in horticulture stuff, and really perfected a method of bringing that high quality product. So, I think that's a really good take home point, is be careful with, looking at that stuff, and, look at the quality as well as all the other stuff coming to market. So any other closing thoughts for you guys before I wrap it up with it for today?
No, just thanks for the opportunity to talk about that, and thanks for the audience for listening. And we just basically touched on briefly on a huge subject. So like you said, we could have talked for hours. We didn't even talk about azobacteria and other nitrogen solubilizing or creating bacteria. That's a lot of work going on with that, especially in cereal crops and that at the moment too.
Yeah, definitely. I'll second that, Darren. Thanks for everybody to showing up today and participating. And I really enjoyed talking with you guys about the soil, something that's very dear to me, and really appreciated the opportunity. And we're there. We're available for more talks or more questions, or if you're looking for additional resources, contact the rep, contact us, and we'll do our best to provide you with some good, credible, reliable info.
Thanks, Mark. Thanks, Darren, for joining us. Kind of a new way we're going to start doing some podcasts if everybody likes it. So thank you for joining us for this. I echo everything that Darren and Mark had said. So please join us. I believe our next one is November 3rd. I believe around the salinity and alkalinity in our soil we're working on. So stay tuned for some stuff on there. And please check out our websites if you need some resources. And yes, reach out to a Taurus rep or anybody who can help you. We're very passionate about all this stuff. Agriculture alone, let alone the products within the AgTiv portfolio. So thank you very much, and enjoy your day.